This video is on graphing polynomial functions. Before we graph, we're just going to look at some different ideas about polynomials. So the degree of a polynomial function is the value of the largest exponent. The coefficient of the term with the largest degree is called the leading coefficient. So we're just going to look at a polynomial function so that you can understand what this means. So we have to look at all the exponents. We have a 5, a 4, a 2, and remember this would be 1 because x is technically to the power of 1. So we just need to find which one has the largest exponent. Well, it's this first one here that has 5 as the exponent. So we know the degree of this polynomial is 5 because it's just find the largest exponent and that's the degree. So the coefficient is just the number multiplied by the variables. So like 3 is a coefficient, 4, in this case -1, 2, and -5. So the coefficient of the term with the largest degree is called the leading coefficient. Because 5 is the largest degree, largest exponent, it means that 3 is our leading coefficient. So here are two problems. Go ahead and determine the degree of each. And when you're ready for the answers, go ahead and come back. All right, the degree of the first one. The largest exponent is 4. So our degree is 4. Number 2, the largest exponent is 5. So degree is 5. And if you wanted to identify the leading coefficients, so in the first one, it should be -4, and in this one, it's a little more tricky. Technically, there is 1x to the 5th, so the leading coefficient would be 1. All right, next idea having to do with polynomial functions. The real zeros of a function are found at the x-intercept. So this is the point where your graph crosses through the x-axis. Okay, because polynomials have different degrees, we can kind of determine approximately the number of times that the graph will go through the x-intercept or the x-axis. So if the exponent, the degree, the largest exponent, is an odd degree, there will be an odd number of zeros. So an odd number of times that your graph goes through the x-axis. If it's an even exponent, it'll go through the x-axis an even number of times, so there will be an even number of real zeros. It doesn't tell us the number of times, it just tells us if it's an odd or an even number. So if you find out that you graph it and it only goes through twice, yet it was an odd number, you probably made a mistake somewhere. Okay, so we're going to use these concepts, these ideas, and we're going to graph. Okay, so when you graph a polynomial function, you want to just create a table of values. So I'm going to just pick some x values I want to plug in. I'm going to plug them into my function, and I'm going to get y out. So I'm just going to use values that I can graph on this coordinate grid. It just goes out to 10 on each axis. So I'm going to plug it into x to the 4th plus 2x to the 3rd minus 3x squared plus 2, and I will get out different y values. All right, so I'm going to plug in -4, and I'm just picking values. I might have to go further out. If I find values that go way off the coordinate grid, those aren't values I can use, so I'm going to move in closer towards 0. But if there's still points on the coordinate grid, I want to move out because your polynomial function will have curves in it. It will be a curved graph. It won't be like V-shaped at all, but it will go off the paper at some point. All right, so when I plug in -4, I get -4 to the power of 4 plus 2 times -4 to the power of 3 minus 3 times -4 to the power of 2 plus 2. So I'm going to suggest that you just type this into a calculator. If you want to work it out by hand, that's fine. Just remember when you're typing it into a calculator, you need to put a parenthesis around values that are negative. Because if you just type in -4 to the power 4, your calculator is going to do 4 to the power 4 and put a negative in front of it, instead of doing -4 to the power 4. So -4 times itself 4 times. So go ahead and type it into your calculator. I put this one in already and I got 82 as the answer. All right, so that's way off my graph. So I'm going to see if the value of where x is -3 is closer down on my graph. So I'm going to plug it in, -3 to the 4th plus 2 times -3 cubed minus 3 times -3 squared plus 2. And this one I got 2 out as my answer. So I'm going to plug in -2. And it is easier to write it out so you make sure when you're typing it into your calculator you do it correctly. So -2 to the 4th plus 2 times -2 to the 3rd minus 3 times -2 squared plus 2. Also be sure that you do not multiply the base numbers together before you do the exponent, because this is just -2 to the power of 3, then it's multiplied by 2. It's not 2 times -2 all raised to the power of 3. So just be careful of that. All right, so on this one, I got out -10. So I'm going to plug in -1 for x. So we have -1 to the 4th plus 2 times -1 cubed minus 3 times -1 squared plus 2. And my answer was -2. And I'm going to plug in 0. Oops. Plug in 0 and I get 0 to the 4th plus 2 times 0 cubed minus 3 times 0 squared plus 2. And as my answer, I got out 2. So I'm going to plug in 1. Now again, I'm going to see as I increase in values if any go off the coordinate grid, and then I can stop plugging values in. So I have 1 to the 4th plus 2 times 1 cubed minus 3 times 1 squared plus 2. And this, I got an answer of 2. So now I'm going to plug in 2. I get 2 to the 4th plus 2 times 2 cubed minus 3 times 2 squared plus 2 gives me 22. So I know that that one goes way off my graph. So I know that I don't have to keep on plugging in any larger x values. So I'm just going to start graphing. Okay, so here's my coordinate pair. When x is -4, y is 82. Well, that goes way off, so I'm not going to graph that. But when x is -3, y is 2. When x is -2, y is -10. When x is -1, y is -2. When x is 0, y is 2. When x is 1, y is 2. And when x is 2, y is 22. Again, I can't graph it, but I can estimate where my graph would go through when the y value is 10. I'm going to say it's probably like 1.5. When x is 1.5, y would be 10, because that would be approximately halfway through there. And to know where this, I know that my graph didn't start way down here, it didn't start way over here. I knew when x was -4, y would be 82. That means that it's way off the graph. So it goes through my graph closer to when y is 10, the x value over on this side would be closer to -3. So I'm going to say it approximately goes through right here, just so I can identify the point where the line goes through the graph. Okay, so I'm going to connect these, but again, they need to be curved. They are not, you don't have sharp edges. It's not V-shaped, so I'm just going to come down, and I have to get way down here and kind of round up as much as possible. Make it look rounded. Come up here and then come up again. So this is what my graph looks like, and I can put little arrows because I know it's going to continue. All right, so the idea of the degree. My degree is 4 and it's even. Okay, so then the idea of zeros. The number of times it goes through the x-axis. Well, it went through twice, 2 x-intercepts. Both are even, so, well, I know that potentially I've graphed it correctly because, well, I didn't go through an odd number of times. All right, so I want you to use this idea of creating a table and then plugging the points in to graph it. I'm going to give you a couple of problems. I'm just going to zoom out so you can see. All right, first one. F of x equals -4 times x cubed minus 4x squared plus 2. And number 4, f of x equals 2x to the 4th plus 3x cubed minus 4x minus 5. Go ahead and graph them. Use the table, create tables, plug the x values into your equation. I suggest using your calculator to figure out what they equal and then plot the points. Again, double check, see if your degree is odd. Does it go through the x-axis an odd number of times? If it's even, does it go through an even number of times? Come back when you're ready for the answers. All right, so this third one. Okay, so I already figured out what the values were. So I plugged in when x was -2, and I got out y is 18. So again, I wanted to know one value where it was off the graph so I could figure out where it came from. So when x was -1, y is 2. When x is 0, y is 2. When x is 1, y is -6. And when x is 2, y is -46. So this one went off the graph on the other side of the x-axis. So then I'm just going to graph. Well, when x is -2, y is 18, so it goes off way up here, so I'm going to say it's potentially going to go through about there. So before I get to -2, when x is -1, y is +2. When x is 0, y is 2. When x is 1, y is -6. And when x is 2, y is -46, goes way down there, so I'm going to say it's about there. Okay, again, I'm going to connect my points, try to be curved, no sharp corners. This is about what it looks like. I only had one x-intercept, and well, I can see that my degree is odd and my number of zeros is also odd. All right, one more. Okay, we have x values that we can plug in, and see, I already did this, so I plugged in -2. I got out 11 for y. Plug in -1, I got -2 for y. When x was 0, y is -5. When x is 1, y is -4. And when x is 2, y is 43. All right, so then graph these. This one's just barely off the graph, so I can graph it. When x is -2, y is 11. When x is -1, y is -2. When x is 0, y is -5. When x is 1, y is -4. And when x is 2, y is 43, going way off the graph. So I know it's going to go off the graph quite a bit before we get to where x is 2. So this one's a lot closer to where x is 1. All right, then I'm going to try to connect my points, again curving. Come back up. And it goes through the x-axis twice, so 2x intercepts, so 2 zeros, even number of zeros, and even degree. All right, hopefully you were able to graph the polynomial functions.